This is a lesson about graphing the sine and the cosine function, and this is part one of the lesson. We're going to start with a couple of easier examples, more basic examples in this video, and then the next video we'll do a couple fancy graphs. But basically we have learned in class about unwrapping the unit circle using the ones and zeros at 0, pi over 2, pi, and 3 pi over 2, 2 pi radians. And we have come up with the fact that the cosine function, the basic function, would start up at 0, 1, and go to 0, and then down to a minimum value at -1, and then up to 0 again, and then up to +1. So if this was the origin, and this was the x-axis and the y-axis, cosine would make a cup, a big C, over the origin. So one complete period on the right-hand side of the y-axis looks like this, and these would be the 5 critical points. And if I laid a bunch of these next to each other infinitely, I would have a continuous cosine curve. The sine curve, instead of starting at the top, starts in the middle. So this would be the origin of the parent function of the sine curve, just y equals sine of x or sine of theta. And it would go up, and then back to the middle, and then down to the bottom and up, and we get these nice smooth curves. So we're going to use words, when we look at this basic form of the equation, we're going to be finding the amplitude of the function, which we'll talk about in a minute. It's the height up and down of the function. A baseline of the function will just be the horizontal axis that divides the function in half vertically. We'll talk about the maximum and minimum values of the function, the period of the function, this is how long it takes it to roll out horizontally in one complete cycle, and how to find the left edge and the right edge of the function if it starts at a place other than at the y-axis, other than at 0. So first of all, just some terminology about the basic function, the basic form of the function. And we won't always have values, but there would be numbers for A, B, C, and D. And some of the time, we'll only have one number, or 2, or 3. We won't have all of them, especially in our more basic graphs. So this goes for cosine and for the sine function. These are interchangeable. Also, where I put an x here, this is whatever you're measuring on the horizontal axis. It could be angle measure in degrees, it could be angle measure in decimal radians, it could be in pi radians. So it's just the angle measure. So this is interchangeable with theta. So A is called the amplitude of the function, and it shows, it causes the function to stretch vertically, up and down, taller, and so it actually changes the shape of the graph. So does B. B changes the shape, but it changes it horizontally. It either stretches or compresses horizontally. So the idea is when A is a big number, the amplitude is big, so the wave goes up and down, really high and low. And when A is a small number, the wave gets vertically compressed. When B is a small number, the opposite things happen. This tells you how fast the function moves about one cycle from left to right. When B is a small value, this is kind of a slow function, and it takes a long time to complete one period. So when B is small, this stretches out horizontally. When B is a big number, it means it's a fast function, and it can complete a cycle in a shorter period, so it gets kind of compressed horizontally. So C and D don't change the shape at all. They just shift the function up or down. D, if it's positive, the function goes up. If it's negative, the function goes down. Because this is in the format x or theta minus C, this moves C units to the right. So if it's x plus C, it means x minus negative C, and it would move left. So minus moves it right, plus moves it left. So let's do just a real basic example. And we're not going to use anything but the A and the B in this example, and we'll graph a cosine. So we're talking about y equals 2 times the cosine of 4 times theta. And again, theta is interchangeable with x. So in this, the A is a 2, and B is a 4. So I'm going to find the amplitude of the function, and that's the A. I'm going to find the maximum value, which I'll use capital M, is going to be a positive 2. That's the amplitude. It goes from the y-axis, it goes up to 2, and the minimum value from this amplitude is negative 2. From the y-axis, it'll go down by 2 for its highest and its lowest points. And then I'm going to find the period of the function. And so from our beginning sheet, we see that the amplitude is the absolute value of A. The period is always 2 pi divided by B. So in this case, it's going to be 2 pi divided by 4. So that's pi over 2. So this function completes a whole cycle. So it's going to make this shape in half the time that the parent function would. It's a fast function. It's 4 times as fast as the parent. No, it's a fourth of the time. Sorry. So what this can do in 2 pi, because its normal period is 2 pi, this can do in half of pi. So it's a fourth of the time. So then what we do is I'm going to draw my long horizontal axis. In a vertical axis, it has to be deep enough to get me up to 2, positive 2, and down to negative 2. So the highest point the function will hit is positive 2, and the lowest point, the minimum value, is negative 2 from here. Then the period is pi over 2. So I'm going to come out here and mark a point, and it's equidistant from this. So I'll make this pi over 2 and negative pi over 2. Then what I've got to do is divide this into 4 equal parts. So I can take, I take pi over 2 divided by 4, and I see that each part will have a width of pi over 8. So anyway, what I usually do is just take this whole distance and divide it in half. So halfway between 1, and I can think of this as 1/2 of pi. So halfway between 0 and half would be a fourth, so this is pi over 4. And halfway between 0 and a fourth is an eighth. And halfway between a fourth and a half, this would be 2/8, and this would be 4/8, so this would be 3/8, or 3 pi over 8. And by the way, on this axis, this is theta, or x, this is the measure of the angle, and this is y-axis, the value of the function of cosine. So then I'm going to do the same thing over here. So this will be negative pi over 4. Negative 3 pi over 8. Okay, so anyway, the left edge of this function, just on the positive side, is the y-axis. And so I look, now I'm going to start plotting the points. So I look at, you got to really memorize or know this, what one period looks like from 0 to 2 pi of a basic cosine function, or from 0 to the end of its period. So cosine always starts up at the max. So I'm going to start here and go down to the middle, and then down to the negative 2, and then up to here, and then back up to where I started. And so this is a cup like this, and then I come like this, and then I go like so, and that will continue. Now I remember that cosine is an even function, so I will have y-axis symmetry. So every point here is going to reflect perfectly onto the other side. So I have a point here, and then my minimum, and then I'm here again, and then up here. So I always end a period where I start. Okay, so that is 2 times the cosine of 4 theta. And, what I usually do is I dash in my max and my min, because I know the function is going to have a range in y inside that band, and helps me plot the critical points. Okay, so then the second one I want to show you is also just going to use y equals a and the b, but I'm going to do a sine function, and this one is going to be y equals 3 times the sine of theta over 2. So I'm going to write that in a form that might look a little bit easier for you to see the a and the b. theta divided by 2 is 1/2 theta. So now I can see in this function that the a value is 3 and b is 1/2 from this form. So the amplitude of the function is the 3. The maximum value is going to be positive 3. The minimum value will be a negative 3. The period of the function is 2 pi divided by b. So in this case, 2 pi divided by 1/2. So that's 2 pi times 2. So that's 4 pi. Okay, so when b is a small number like this is a slow function. What the parent function can do in the regular period of 2 pi, this takes 4 pi to do. It moves out slowly, so this has the effect of stretching it horizontally. So, do my x-axis. I'll put a little y in the middle. This has an amplitude of 3. Maximum in of 3 and negative 3. I'll sort of dash in where the maximum in will be. And so anyway, now I'm going to take this and make this equal to 4 pi between the y-axis and that. So I'll come over here and that'll be negative 4 pi. So splitting this in half, this is 2 pi. So this is 1 pi and 3 pi. Doing the same over here. Okay, so I've divided the period into 4 equal parts, and then I look at the sine function. And in the basic picture of the sine function, I remember that sine starts in the middle of the function and goes up to the max and back and down. So the 5 critical points will look like that always. And so sine will start here. It goes through the origin right there, and then it goes up, and then back to the middle, and then down, and then back to the middle. So on this side it looks like so. And on the left side, remember that sine is an odd function. So it's not going to be symmetrical about the y-axis. It's going to be symmetrical about the origin. So all of this point will be reflected down here. So I'm going to go down and up, here and up and down. So kind of making these smooth cups. So again, you can see that if I take a ruler through those 2 points, they go through the origin. That's origin symmetry. Or maybe through this point and this point goes through the origin symmetry. So that's the function 3 times the sine of theta divided by 2. And that's it. So my best advice is to keep practicing and remember what all the parts mean. Remember that A and B change the shape, and in the next video we'll look at C and D and how they change, how high or low, or they shift the function up or down or left or right. And that's it.